All right, so welcome back. Today in this video, we are going to be starting our statics review for the Civil FE exam. There's quite a few different sections that we'll be looking at, starting with resultants of force systems and ending with static friction. So I have a few problems that I want to go through. They can be a bit complex, and this is where the test begins to get pretty technical. So let's go ahead and dive in. This stuff isn't crazy. We just got to break it down into its simplest form. So start with number one. All right, so number one says a force of 50 newtons is applied horizontally, and another force of 30 newtons is applied at an angle of 60 degrees to the horizontal. What is the resultant force? All right, so what information are we given? All right, well, we're given two different forces. Okay. One is horizontal, and then another one is 30 newtons at an angle of 60 to the horizontal. So you may be wondering what that looks like, and I'll draw it out just so it makes sense. Okay, what are we trying to find? The resultant force. Okay, so if we're trying to find the resultant force, what formulas do we need? So just going out on a whim, I'm going to search resultant in my FE handbook. Resultant. All right, and 11 things come up, and now we find that we're in the static section. So if I zoom in here, this says the resultant, two dimensions, is the resultant F of n forces with the component Fx and Fy has the magnitude of F is equal to the sum of the forces in the X direction, are a little harder to see. Sum of the forces in the X direction, that's what this is in parentheses, squared, all right, squared, plus, I'm gonna zoom in a little bit more, plus the sum of the forces in the Y direction, squared, and then all to the 1/2 power, which is ultimately saying all over the square root. So that is what the resultant force, that's the resultant force, F. So do we know the sum from the information that we're given? Can we find the sum of the forces in the X, the sum of the forces in the Y, put them into this equation and get F? I think that we can. So let's draw this out, just from a diagram standpoint, right? So just gonna draw like a X and Y axis. This is X, Y. Okay, so one of the forces is 50 newtons horizontally. So I'm just gonna say, draw it with a different color. Let's say this force is 50 newtons. I know I'm drawing small, but it's only in the horizontal that it's going to the right 50 newtons. Okay, it doesn't say a negative, so I'm drawing it in the positive direction. And then another one is 30 newtons. at an angle of 60 degrees, so to the horizontal. So from here to here is 60 degrees. And we have this force coming up. And that one is going to be 30 newtons. Okay. We have two forces, the one in the red and the one in the orange. So how do we get this to match our equation? Well, first we need to know the forces in the x, right? The first portion of this problem. So what are the sum of the forces in the x direction? Sum of the forces in the x is equal to, well, we have the 50 newtons, the right, that's positive, plus, this is where you use your trigonometry skills, 30 cosine of the angle that's in between, which is 60 degrees. Remember, cosine is always it's always going to be, and we can check it, but to get your x's, it's always going to be the force cosine of angle. All right. If you want f of y, cosine of the angle to the y-axis. So this is to the x-axis. So it's 60 degrees. All right. So what does that, when we do the math on that, what does that equal? Well, that equals 65 newtons. All right. What about the sum of the forces in the y? Because that is the second half of this equation. Sum of the forces in the y is equal to, well, our first force is all horizontal, so it's no force in the y, and then our second force is 30 newtons, and so it's going to be, should be 30 newtons times sine 60. And I'm putting it in my calculator. I like to make sure that I have answers in, make sure your calculator is in degrees. Okay. So we're going to get 30, 60. Yeah. As I'm saying that, my answers are coming out weird. So I'm like, what is going on? And I had it in radians. So I always want to make sure that you have it in the right number. So this is going to be 25.98 newtons. All right, so we have the sum of the forces in the x. This piece, just got to break it up in pieces. Sum of the forces in the y, all right, which is our 25.98 newtons. And we also need to now put everything in our equation to get our resultant force. So the resultant force is going to equal to F, which is equal to, I'm going to write this in terms where it makes a little bit more sense. So the sum of the forces in the x squared plus the sum of the forces in the y squared And then we want to take the square root of all of that, all right? Basically the magnitude. All right, so now we just plug and chug, all right? So f is equal to the square roots of 65 squared, and then plus 25.98 squared. And now get our force or resultant is equal to roughly 70 newtons. So our answer is going to be C. So once you understand visually what's happening, then you can break up all this complex crap that's on here to just know that it says it's the sum of the forces in the x direction. And the reason why they put all of this on there, because there could be multiple different forces, right? So you could have 10 different forces that are all going every which way, but ultimately you're going to have to still take the sum of the forces in the x directions from all of those different forces, or all of those different places that the forces are pointing to. Okay, so hopefully that made some sense. Let's look at number 2. All right, so number 2 says a force of 30 newtons is applied at an angle of 45 degrees to the horizontal. So let's draw this out real quick so that we're not confused. All right, we got a force. You got 45 degrees separates angle, and it's 30 newtons. Okay. What is the horizontal component of the force? Okay. So this one seems like not too tough here. We're going to use the same equation, except for we don't have as many angles, right? So we're just looking for the force in the x direction. And so from this, sum of the forces in the x direction is equal to 30 newtons, right? And then cosine of the angle is 45 degrees. All right, and once I do that, I get 21, roughly 21.2 newtons. And so my answer is going to be B. Similar problems, less forces to deal with. Just had one force this time. So kind of skipped a step, but we were given one force. I started drawing. We're trying to find the horizontal or x component of the force. The formulas that we needed was this. And then we solved. Okay. Let's look at number 3. Okay. So number 3 says a force of 20 newtons acts eastward, and another force of 30 newtons acts northward. What is the magnitude of the resultant force? Okay, so what information are we given? We're again given two forces, which look like this. If I draw out X and Y coordinate system, and I put my first force, it's acting eastward. Oh, okay. And that is for, wait a minute. Sorry. That is not east. Try that again. That was westward. All right, 20 newtons. Okay, and then another force acts northward. And that one is 30 newtons. And now you're trying to find the magnitude. Okay, so what formulas do you need? Well, anytime we have magnitude, same as the resultant force, which is F is equal to the sum of the forces in the X squared plus the sum of the forces in the Y squared all over the square root. Okay, so what are the sum of the forces in the X? Should be 20 newtons and nothing else. Sum of the forces in the Y is equal to, should be 30 newtons. And then the resultant should equal to the square root of 20 newtons squared plus 30 newtons squared, which then equals to 36.05 newtons, which is my resultant force, or the magnitude of the resultant force. And that is going to be C. All right, before you just say, okay, this is easy and repetitive, one thing that I do want to point out is when you're solving this, remember this is always the sum of the forces. So let's take a look, and let's say this problem, this is a very key point that I don't want you to get the wrong answer. Let's say, for example, you have one force, you have these two forces that are acting just how they are, and then we add a force, right? And that force is, we'll say, coming down like this. Coming down like that. Okay, and let's say my angle from here to here is 40 degrees, and this is a say is a 50, Jesus Christ, it's 50 newtons. 40, there's 40 degrees, it's 40 degrees from the x-axis, right? All right, so what would the sum of the forces be? I just want you to make sure that you have the right signage. So the sum of the forces in the x would be 20 newtons, right, from our force going to the right. The one that's going up is, it has no nothing to do with the x. What about this 50 newtons now, right? It is going to be a negative 50 newtons. And then what would be, would it be sine or cosine? Well, if we're looking at the x, we're going to do cosine of the 40 degrees, right? Adjacent. Okay. And so that would get us what? 50 cosine of 40, 20 minus second. That's going to give us a negative 18. Basically newtons. 18.3, right? But I was running out of room, so I just said negative 18 newtons. The key thing about this is it's okay for that number to be negative, but and let's go ahead and do the y too. So this one would be 30 newtons, and then would the y be a negative or positive? All right. So it's coming down. My y value is coming down, and so my x is going to the left, which is negative way, and my y is coming down, which is still another negative, so minus 50. And then in this case, it's going to be sine of 40. All right. And that's going to be -30 minus second answer. So I get negative 2.139. Right. Okay. So once you plug this back, say we're looking for the resultant again, right? Then the resultant would be F is equal to the square root of negative 18 squared plus negative 2.139 squared, right? And then you get a value. It is okay for that number to be, it is okay for the sum of the forces in the x or the y to be a negative number, because once you square any negative number, it's always going to change it to a positive. Because remember, you cannot put a negative, you can't put a negative value underneath the square root, right? If you try that, it should give you a domain error or something. So, but for your sum of the forces, it is okay for it to be negative. And so I didn't want to, we used all positive versions in most of the examples before, but I just want you to know that it is not always going to be positive. It depends on where your arrows are pointing. So if it's pointing, if your x is pointing in a negative direction, then you want to use a negative. If it's pointing in a positive direction, signage needs to be positive. All right. So that concludes this section. The next section, we're going to be looking at equivalent